Hi everybody, welcome to the 10th video of Module 8, and here we are going to have some conclusions and the final words about this project. The first thing that I'm going to show you is that how we can implement the confusion matrix on this data, and then what are some conclusions that we can have per classes that we had seen over here. And lastly, what are the next things you can do in order to improve this model. So let's get started. So let's see how we can get this confusion matrix from the sklearn.matrix. So for this, I'll be using confusion matrix, and let's see what kind of inputs it takes. It first takes the true value and then it takes the prediction value. So y test is the true value, y predict is the prediction value. Okay, there is some kind of an error. Classification matrix can't handle a mix of multi-label. Okay, let me just see what is the problem over here. Oh yeah, we need to use y test class and the y predict class. So y test class and the y predict class. So it works fine. If I look into the confusion matrix, it's giving me the output in the format of some matrix. So let's beautify it with the help of Seaborn library. I'm going to import Seaborn as SNS. Now I'm going to create a whole confusion matrix as a heat map from the Seaborn library. So I'm going to give these labels over here as galaxies, quasars, and the star. And as you can see over here, galaxy, quasar, and star is coming. And if I don't use this kind of labels, it's going to give me a 0, 1, 2. So it's not really going to make a lot of sense. And therefore, I've used this labels over here that I'm going to pass as an input to this heat map. So I'm creating this heat map for this confusion matrix. And whatever kind of details you are able to see over here, it's because the anode is equal to true. That is, the annotation is equal to true. Then the square shape of this whole heat map is because of square is equal to true. Then the format is set to D as a placeholder, particularly for the integers we use it. And then the color bar. Because the confusion matrix is pretty much small, we don't really require the color bar over here. And therefore I have set it to false. Then the line width that we have over here, I have set that to 2 to have a clear output, something like this. Then the X tick labels and the Y tick labels, I'm both giving the same list for the galaxy, quasar, and star. And yeah, then I'm just customizing the plot by giving the title X label, Y label, and finally saving the figure as the confusion matrix.png. So this is how it's going to look like, guys. If I zoom out a bit, over here we can clearly see that our model is having a hard time, not that much hard time, but yeah, a little bit amount of hard time in order to classify galaxies and stars as compared to galaxies and quasars. There is a very little misclassification of the galaxy as the quasar as compared to misclassification of galaxy with star. Even though this number is less, but as compared to this quasar, it's a bit higher. And therefore, the initial hypothesis that we were having, that because the distribution of the stars and the galaxies are pretty much similar, we might see this kind of a problem, and it holds true. Apart from that, if I look into the second part, that is the quasar part, even though it was very much less in amount as compared to the galaxy and the star, we had thought that this would not really perform well. But if you notice, it is indeed performing well. And some of it is also getting misclassified as the galaxy, but in a very less amount. This was completely unexpected, knowing that the quasars were very less in amount. And then lastly, if we talk about whenever it was actually a star, 4 times it got misclassified as galaxy and 1 time misclassified as a quasar. So overall, it's a very impressive output, but still you should focus on how you can change the architecture, how you can change the optimizers, cost functions and whatnot in order to get all of these non-diagonal values very much close to 0. So if you are able to achieve it, well and good, but that's exactly how we have got this output over here on the basis of what kind of architecture we have designed, what loss function, metric and everything that we had used for the compilation of the model, and then how the training and the testing has happened. So all of these kind of observations are also mentioned over here. So yeah, make sure that you are playing around with this kind of model and trying to decrease this non-diagonal values as much as possible and make it close to 0. And here comes the final step, that is how we can save the train model. And very similar to what we had done in our one of our earlier module, where we had created a star type API. You can create one API over here for yourself. I am not going to show it to you because you are already aware about how to create one. So as a practice, you can take it and try to create this by yourself. However, in the final leg of this whole program, I'll be creating an API and create a whole web app for the final project that we have in this program. But for now, I would highly appreciate and recommend that go ahead and try to create this API by yourself with the help of Fast API using the same kind of tactics that we had followed while creating the star type API. So let's see how we can first of all go ahead and store this kind of trained model in the file storage over here of the Google Colab. So for this, I'll be requiring to use model.save, and then I can give some kind of a good name. Let's say SDSS model.h5. And if I run this, it's going to give us the warning that now we don't really save it as the h5 file. We use it as .keras, but over here it's going to work. So that's completely fine. And now you are having this model saved over here. And you can start using this by simply downloading it into your system and create an API out of it. And if you're going to do it, I wish you all the best. So yes, we are done with this project over here. I hope you were able to understand that how we got this confusion matrix and what kind of sense it adds in evaluating the whole model. And I hope that you will be implementing some of the steps that I've mentioned in how you can improve the model. And yes, that's about this whole project, guys.